Great. Okay, so in the last class, I told you that um, the loadings, the ultimate design load for an element, for example, is obtained with the relation 1.4 GK, and that's the dead load, plus 1.6 QK, that's the live load. All right. And I told you that the live load varies
Yes, sir.
depending on the usage of the structure. And that's exactly where we want to pick today's class on. How do we determine the life load of different structures that we have? So, referencing our BS 2399, I believe you try to share one of those things with me. All right. So, for the table, I'm looking for the table that speaks of residential occupancy class. So that's table five. Pardon me, I think table eight. So table five.
Okay, table five.
Table five. So I'll be sharing my screen so that you can see the table directly from what I'm doing here. Okay, so what you have now, can you see my table? Can you see?
Yes, I can see it.
Okay, good. Now looking at this table, residential occupancy class. Now this is talking about structures basically for residential purposes. And I think I made a distinction between residential structures and commercial structures. So we're going to see these things briefly. We'll just try to run through them and see what we have. Okay. So from the first one here, you see we have the
Yes, sir.
self-contained dwelling units. You know what we call self-contained, right? Basically. So self-contained dwelling units. The intensity of distributed load. I told you that we have three basic forms of load units, right? And are you with me?
Yes,
And on this particular table, you can see
yes, sir.
of them represented here. We have the intensity of distributed load, and that should automatically tell you what it is. If you can remind me, what do you think it's talking about this? The intensity of distributed load. What are we talking about? Then that should be the uniformly distributed load, right?
Yes,
And then we have
yes.
the concentrated load, which we refer to as the point load. Now, whichever way you want
Point.
to adopt your loadings, all right, there are provisions for that on these two accounts. So, what we have the self-contained dwelling unit. And for the UDL, if you want to pick the UDL to apply in your own design for self-contained dwelling unit, the life load is 1.5 kilonewton per meter. You see that there. But when we move to
Yes, sir.
type 2 residential occupancy class speaks of apartment houses, boarding houses, lodging houses, guest houses, hostels, residential clubs, and communal area in blocks of flats. Now, you see, look at this kind of class. It has already shown you that these are residential buildings anyway, but you see that it has a little kind of difference between your normal building where you live as a person, you know, and in this case, you see that it has a number of people, like in volumes. Now it's higher than the first class when you're talking about boarding houses, guest houses, hostels, clubs, residential clubs. So, so when you see that now, we have the boiler rooms, motor rooms, fan rooms, and the like, including the weight of machinery. So in this case, you discover that the life load has increased. Why? Because of the purpose of that structure. Now it is 7.5 kilonewton per meter. Now imagine if an engineer that doesn't know what he is to attempt to design a motor room or maybe a boiler room. A boiler room is actually a room that contains machine, right? It's a machine container of um something as fan rooms and all of this. You can't compare the weight to that of a normal structure where you just have your chair and your table and all of this. So imagine if an engineer just misplaced the two of them and use 1.5 kilonewton per meter to design a boiler room. Now you discover that even though the building will be standing, but as soon as they load the building with the required equipment, then problem comes, collapse here and there, you know. So and that's why it's important to use the right live load, the right imposed load for your building. What if you are given a project, and this is the question for you. You are given a project and you discover that it's a duplex, maybe 4 bedroom duplex or 3 bedroom duplex, however it is, and you are asked to design it. From what you have here, looking at my screen from your end, what life load do you think you're going to use?
7.5.
You're going to use 7.5. Now, okay, let's look at it. You're saying 7.5, but under the type 2, did you find anything like duplex there? Under this apartment housing,
No,
look at that 7.5. Look at what owns 7.5.
no, no,
Boiler
sir.
room, motor room, fan room, and the like,
Yes, sir.
including the weight of machine. You don't keep machines in a duplex. It's not a printing press. It's not a refinery. You don't keep stuff like that.
Yes,
So if you be using 7.5, you would waste your client money very brilliantly because your building will be requiring large volumes of large sections of elements. You know, where you're supposed to use 450 by 35 beam section, you'll be requiring 1.2 by 35 by 300. That's needless for a duplex. So you have to pick what you're doing right. So we are trying to create a balance between safety, economy, So as much as you are trying to be safe, you are trying to be economical in your design. So picking a very high life load would actually have economic implications. And it's not even right in the first place to talk about. So look to this table again. Under type 2, you can see things like bedrooms. You can see things like dining rooms. You can see things like
yes,
toilet rooms. You can see corridors, hallways, stairs, landing, food bridges. Now, anyways, these ones, you see that they actually treating these elements one after another and not like a building. All right. So if you are designing
yes,
bedrooms,
yes,
if you are designing bedrooms, look at what they said you should use. 1.5 kilonewton per meter is cool enough. At most, for residential structures, you use 2.0. Did you get that?
yes, sir.
Please don't forget. If you're
Yes,
designing a residential building or structure, all right, you discover from this table, particularly type 2, it shows you that all the class of structure that has something like um, dining room, lounges, toilet rooms, bedrooms, dormitories, you see that is within the range of
yes,
1.5 to 2.0.
yes.
So when you're designing a residential building, it is safe to stay within that range. It makes sense actually. So if you're going for 3.0, because you can see 3.0, I was hoping that you asked me that why not 3.0, because you can see corridors there. You can see hallways there. You can see stairs there. You can see landings there, and you can see footbridges there.
Food bridges.
Do you know what footbridge is?
No, sir.
Okay, what is it?
Food bridges.
Yeah.
Um,
It's something you should have you should know already. You see it everywhere. It's all over the place. I'm very sure you'd have seen it today if you left your room Sunday. So, do you see something like a pedestrian bridge?
These are, is it like normal bridges?
It's not like normal bridges. Pedestrian bridge.
Okay,
Just from the word already
okay,
tells you what it is. Food bridge, pedestrian bridge. Now, for that pedestrian bridge, you know that it is expected that it has a high traffic. I mean, a number of people more frequent than the usual usage or the common usage of spaces within residential um, building. So that's why it has a life load higher than odd, like 3.0. You see that? So just like I said, for you
yes,
to be able to take notes when you are working with residential building, it is safe to stay within the range of 1.5 to 2.0. So, but when you are dealing with commercial, then you want to critically look at what you're dealing with and apply it correctly. Look at this boiler room here. I designed a boiler room for Olam Nigerian PLC in Ilorin. That's a steel structure. It has heavy material. So in those kind of that kind of building, you see the likelihood of that as that. So let's look at some more. What if you are asked to design an hotel building? An hotel building. Look to that material you have with you. An hotel room.
hotel,
If you are to design an hotel room, what likelihood are you going to use?
hotels and motels, boiler rooms, this fan rooms, and like it can use a bit of machinery. But for like hotel rooms, you have like heavy stuffs in the building, so it's good if you use like a high load.
From what you have here, what do you think is going to look like? Hotel rooms. I said hotel rooms, so you should have an idea of what I'm looking.
Okay. Mm. In the hotel rooms, you have kitchens. Hello?
Hotel rooms. I just hotel hotel rooms. It's as simple as picking rooms. You see, there are rooms there. The first set of
Yes.
rooms that you saw, where they are meant for the weight of machines. And I never mentioned the hotel rooms that contain machines. I'm just thinking of normal hotel rooms where you go to sleep,
Okay.
right? So you discover that what you have here is dining. You have dining rooms, you have lounges, you have billiard rooms, you have bedrooms, you have toilet rooms, which are normal basic stuff you find in hotel, right? So you discover that all
Yes.
of these things you have where you have. So are you safe?
Yeah, yes, yes, sir.
Now look at this. I told you about seating, fixed seating. Maybe in the hotel, in all these big hotels, maybe they have cinema or something there. And in that cinema hall,
Yes.
there are usually seats. And it's also an assembly area, whether we want to agree or not. Any place, whatever, that receives a number of people where they all come together, it's an assembly area. Now, the fixed seating I spoke about is an example I'm trying to show to you concerning the stadium where the seats cannot be adjusted or moved or lifted because it is somehow connected to the platform. That's exactly what you're seeing here. Assembly areas with fixed seating. So in those kind of scenarios, your outload will be. Now, if you maybe you need some extra explanation to that, if you look at the last line on this page, What can you read from there?
Fixed sitting is sitting where its removal and the use of the space for other purposes is improbable.
Did you see that?
Yes, sir.
Its removal and the use of the space for other purposes is improbable. So I've been able to explain that to you. All right, so you can look to there are different places. Look at we even have institutional and educational occupancy class. For example, prisons, hospitals, schools, and colleges. So this code of practice is basically for the loadings. So talk about the X-ray rooms in the hospital, talk about the projection rooms in whatever place we're talking about, talk about the drill rooms or flight galleries. All of those things are there. So that's all about this. I've been able to give you that document. Take your time to acquaint yourself with it because you will start to reference some of the things as we go on. Okay, so let's go forward. Now let's do load estimation and distribution. The work is about to start. Now, anything like that. I can write that.
Sir?
Can you see my whiteboard?
Yes, yes, sir.
Now, now knowing full well that a structure forms a chain of loads being transferred from one element to another. It is also important to understand that the load distribution, it's also important to know the load distribution, just like what I've told you earlier. Now, what I'll be doing today is that we'll try to understand the estimation of loads, and afterwards we'll see how we transfer them from one element to another till it gets to the bearing strata. All right, so I want to draw a figure. I want to draw a figure. I'm trying to draw a general arrangement drawing. Do you know what a general arrangement drawing is?
In general,
Arrangement drawing.
no?
Okay. A general arrangement drawing is a drawing that shows to you the information of all the structural elements within a structure. It gives you the information of the sizes, the shapes, the dimensions, the types, characteristics, the material information of all the elements that you see. Okay, so I'm going to show to you. You can see my phone.
Yes, sir.
Okay, great. So, what I'm trying to draw now is a beam. And this is a beam. This is also a beam. You guys had your conversation already, right?
Yes, sir. Last 2 months, November, last month.
Okay, last month. Okay.
Yes.
I'm trying to make it as neat as possible so that you wouldn't have to keep assuming things up again. Now, the red colors are grid line basically, and the other color they represent beams. Now, the shaded part is the column. Alright.
Yes.
Now, this is let me put a grid some grid lines so that I mean dimension. It is 2 meters. It is 4 meters. Now, I hope you heard about a one-way slab, a two-way slab, stuff like that. Have you?
Yes.
Now, let's now test that. We want to determine what kind of slab, determine the slab type. Now,
Um,
the aspect ratio, let's call this panel one. Panel one. I will call this panel two. Now, the aspect ratio, which we know as the Ly over Lx, is equals to the Ly is 7 meters, Lx is 2 meters, and that will be what? If you are considering this, what's going to be the
um, that's 3.5.
3.5? Now, because what we have here is greater than 2.0, you know that normally from our background knowledge, when Ly over Lx is greater than 2.0, it is what? One way slab. Think that, right?
Yes.
So that's why this will be a one-way slab. Now let's assume that the result of this also gives a one-way slab. I said let's assume. So by the time you calculate it, it might not be so. But we are assuming it to be so. But this is actually correct. Okay. Now there's a reason why I'm assuming this because I want to show you how to estimate for the slab and then distribute for a one-way slab. So that's why I'm making such assumption. Okay. So you want to pardon my assumption at least for class. Okay, so how do we distribute the load for one-way slab? How do we do? So, but before we talk about load distribution, I want to show you how to estimate the loading for a one-way slab. All right. I mean, for a slab, any slab, however it is. So, let me call it load estimate. All right. So, assuming that the usage, the floor usage is residential. What do you think that implication is?
Assuming the floor usage,
Residential.
our this one to be 2.0.
All right. The the life load. You didn't say it well.
Yes, sir.
It's not our destiny. The life load range from 1.5 to 2.0. So you'll be safe to stay within that range. Okay?
Okay, sir.
So, and our partition, let's assume it is 1.5 kilometers per meter square, and finishes 1.2 kilometers per meter square. So how do we do that for loading it? Loading it. So for this now, the first thing you want to load is the slab own weight. That is the weight of the slab itself. And what's the weight of the slab itself? That's the thickness of the slab. So we get the thickness of the slab to be 150 mm, 150 mm thick slab. All right. So that should be 0.15 times the density of concrete, which is 3.6 kilonewton per meter. Or in case this meeting
Okay.
stops now, I'll provide you another link so that you can get ourselves that type of comfort. Now, the second thing is the finishes, which we said to be 1.2 kilonewton per meter. And the third one, partition, which we said it is 1.5. All right. So the total, this constitutes the dead load, which gives 6.3 kilonewton per meter. Did you get that right?
Yes, sir.
Are you sure? Are we good?
Yes, I can see it.
All right. So the life load, just like we have already said, will be in the range of 1.5 to 2.0. So we can say 1.5 at least for now. The network might not really help us, but let's just stay with it. Okay. So the next thing we're going to work on is to determine the ultimate design load. And I think I told you how to look for the ultimate design load in the last class and the earlier hours of this study. So we have 1.4 GK.
1.4 GK plus 1.6 UK.
Now in this case, it will be 1.4 multiplied by 6.3 plus 1.6 multiplied by 1.5. So that will be what?
8.82 plus the final answer would be 11.22.
Now this is the load on your slab. This is the load on the slab. Now I want you to do something. I insisting about. I want you to do
Yes,
something.
sir.
Now let's assume that this load in your chamber, let's assume it was panel one. So let's assume it's for panel one. I want you to obtain the loadings for panel two, panel two, with this information. A let's see, a hotel room. The second one will be for a boiler room. The third one will be for, let's say, let's say a stadium. So I need the loadings for these three um residential classes. I mean, sorry, slab usage, floor usage. All right. And I need it. If you can complete it tonight, I'll be glad. Or before Monday, our next class, I'll be glad. I'm sorry, I have a function on Monday, but I'll let you know how would I
Okay.
you surely have it. But I need you to do this and get it to me before Monday.
Okay.
So
Sorry, sir. The thickness is still 150.
now this is what I want you to do. I want to use 200 for stadium. I want to use 150 for hotel room and 175 for boiler room.
Okay, sir.
Yes. So that's what I want you to do. If you encounter any problem,
200 stay.
just let me know.
Okay, sir. Let me try and solve it now.
So please do. And then get them to me. But I'll check. And then the next class, once I discover that you're able to get all those things here, next class, I will teach you how to distribute this. For example, the beam is supposed to receive the loads of this slab. So I'll teach you how to transfer the load of the slab to the beam. All right.
Okay, sir.
Yes. For a one-way slab and for a two-way slab also. Then we'll go into the preliminary sizings of elements, how to pick your initial sizings for elements, and then we'll go to the design of individual elements. Okay. So please get this done, and then we'll see how God help us achieve the next step. Do you have any questions?
No, sir. Sir, for the finishing and partition, it should still be the same thing.
Exactly. If I say that you
Okay,
is
sir.
correct likely also.
Sir?
I said you should ensure you use the correct likely.
Yes, sir.
Yeah. So that'll be all. Thank you very much. See you
Okay, sir.
on Monday.